So without further delay, here's your Delphi instructor.
Hi, I'm Dave Hobbs with Delphi Product and Service Solutions, and welcome to this 1-hour live webcast on promoting and profiting with hybrid electric vehicle service. Let's get started with talking about what we're going to have for you in this hour of great live training. We're going to talk about why you need to promote hybrid service in your shop and how to promote that service. We'll also talk about the tools you need to service the hybrid vehicles and electric vehicles of today, and also the training you're going to need to work on these vehicles. We'll also have some live training talking about various components and so forth, as well as some pre-recorded demonstrations and tech tips for diagnostics that we did on this Prius right behind me. So let's go ahead and get started. I hear these top 2 excuses why I'm not working on hybrids in my independent repair shop. Number 2 excuse is, it's too much money to gear up for all the equipment I need to service hybrids. Well, that's not going to fly, as you'll find out in this broadcast. That's a simple thing to take care of. And then the very most common excuse I hear for why I'm not servicing hybrids in my repair shop is, hey, I don't see that many hybrids in my shop. Maybe an oil change once in a while on a Prius, but for the most part, they're just not breaking, they're not coming in. Well, they are coming in, they're just maybe not coming into your shop, and there's some remedies for that I want to cover with the business side of hybrids before we get into the tech side of hybrids, which is going to be most of the content in this next hour. So, talking about the numbers, why you don't see so many of them, there are a few out there, a few as in 3.5 million registered hybrids, and that's just the passenger car population on the roads today in the United States. And the numbers are growing. Corporate average fuel economy and EPA standards on lowering emissions have all been contributors to making this not just a fad that's passing, but a growth area that's going to occur more and more. And so if you knew there were going to be a lot more Euro cars or Asian cars on the road in the next 3 or 4 years, it would be sensible to assume you're going to embrace those cars. Well, the same thing goes with cars like diesels and hybrids. Hybrid owners, on the other hand, they're not bringing their Priuses and their Honda Insights into independent aftermarket repair shops for the most part because they assume their vehicles are so complicated that the independent repair shop can't handle it. They may bring you their F-150 or their Chevy Impala, but they don't bring you their Prius. Why is that? The assumption that it's too complicated for the independent repair shop. It's got to be a dealer-only thing, and we're going to show you how to dispel that myth. Now, the numbers of hybrids out there, of that 3.5 million bulk out there on the road, over half of them in blue, as you see, are Toyota and Lexus. So the family of Priuses and Camrys and different Lexuses out there, with Prius being the huge bulk of the hybrids, is well over half the hybrid population. With about a quarter we see with the Hondas, the Civics, the Insights, the Accords, and so forth. Another quarter, almost a quarter, would be the Fords, the Ford Escapes, and the Ford Fusion and cars like that. So they're out there, and if you do just training on Toyota and Lexus, you will also be very well equipped to know Fords and Nissan because they're very close cousins technology-wise, as we'll find out here in the next minute, to the other hybrids or to each other, whereas Hondas and General Motors and some of the other manufacturers are enough different to where you might want to do extra training on those vehicles as well. Now, it's just not those gas-sipping small compact cars that are hybrids. It's also full-size GM pickup trucks and SUVs during the mid to late 2000s. And as we see going forward, medium-duty trucks, Allison Transmission producing a driveline with a transmission and a Delphi battery pack and power electronics. That's the inverter and converter. Those are in medium-duty trucks as well as in the heavy-duty stuff such as transit buses that you'll see with the big pod on the roof. Those are hybrid vehicles as well. J.D. Power's 2012 survey said that 71% of the future vehicle purchasers are looking for just a conventional old-fashioned car, not a hybrid electric vehicle. However, that does leave almost a quarter of your customers that are considering their next car to be a Toyota Prius or Ford Fusion or Ford C-Max, something like that. So why not embrace it and increase your car count in your shop? Be the only independent repair shop maybe in your area of town or even in your city that does hybrids, and watch the vehicles come. How do you let customers know that you're not the independent repair shop that can't work on hybrids? Well, simple advertising within the signage of your own shop and on your website. For example, if you promote ASE, if you have ASE certified techs, why not have some of them go out and get the ASE L3 Advanced Hybrid Specialist? Now, it's a tough test, but there are plenty of programs on the market which your techs can watch and pass the ASE L3. It is doable, and it will also show your customers that you care. Also, showing your customers you care with your own blogs and your own website with education for hybrid owners, as well as various hybrid owners news groups like the Prius news groups and so forth. Once you get established in there, watch the car count increase as you see more and more of these vehicle owners trusting you and bringing these very, very complex vehicles into your bay. Now, if you have the need to purchase a shuttle vehicle or errand running vehicle for the shop, why not choose something like a Prius? Everybody recognizes that image of the Prius, for example. Put some signage on there with your shop name and phone number, and like, we service hybrids. A lot of shop owners I know are doing this, and they're having good reports coming in of increased car count from a little simple signage on the side of their vehicles. Now, for the little excuse that I don't have enough money, this is going to be a very expensive thing to jump into. What do I need to service hybrids? Have to have versus nice to have. Have to have would be personal protection equipment. Now, you've already got safety glasses. I'm going to assume that's important to wear in case of a flashover, if in God forbid some circumstance where you have a shorted condition with a tool or whatever, molten metal can fly into your eyes. So wearing safety glasses, a great idea. This is an essential thing, though, the personal protection equipment, Class 0 1,000 volt gloves. We're going to go more detail about how to check them, when to wear them, and all that kind of thing coming up. Maybe a $150 investment at the most, and then making sure your meter isn't already Category 3, CAT, C-A-T, 1,000 volt rated. Chances are it is. Other high-end meters and instruments on the market, like from your tool truck, may also have that on there. You want to look in the lower right-hand corner of the instrument. It will tell you what it's rated for. If it's Category 4 and 600 volts, which I'm seeing that on some meters today, that is fine if you're not working on a Prius. A Prius is one of the few that actually will have above 600 volts. There's a part inside the inverter called the boost inverter. That device changes the 200 and some volts of DC to a higher voltage of AC to be applied to a motor generator that propels the vehicle. So to assist the gas engine with extra acceleration, we'll jump from 200 and some volts to 650 volts, making a 600 volt rating of a Category 4 insufficient. So you want Category 3 is as high as you need, and you need a 1,000 volt rating. And that also applies to the alligator clips as well as the leads that you use with your meter, and even the probes that you're going to use as well. So check out the little stampings. This one right here in this picture is only Category 2, 600 volt rating. So the Category 2 is lower than 3, no good. And of course 600 lower than 1,000. Category 1 is too low. 1,000 volts is great, but it's got to be Category 3/1,000 volts. Now, nice to have, not absolutely necessity. But that would be your call, though, because Ford dealerships do require this tool that comes in somewhere around $600–700, and that's called a safety hook. Ford actually calls it a technician release tool, and it gets that term because if a technician were to inadvertently get a hold of something that is high voltage and electrocution starts taking place, they can't let go. The muscles contract. As much as you want to let go of that thing that's hurting you, maybe even killing you, you can't. Now, a buddy can come by and try to pull them off. They'll get electrocuted as well. The really thing you want to do is shut down the power source. Any electrician will tell you that. However, sometimes you can't always do that. So that pole, which is required to be in the bay of a Ford dealership servicing the high voltage section of a hybrid, needs to be right there. I know some instructors that won't even do a live class where we're doing hands-on with students unless they have the pole with them. So nice to have. I would add it very quickly after I got my gloves and ensured I had the right kind of meter. Some more nice to have would be insulated tools. When you're working in the back of a Civic hybrid, for example, and you pull the seat cushion out and you pull then the seat back off, exposing a panel which you'll remove to get to the battery pack and the power electronics, the inverter and the current inverter, you are in very close proximity to some high voltage. So should you be required to power something up, or maybe something hasn't powered down and you have regular old metal tools, that can be an issue. So insulated tools coming in around $600 or $800, and then a category 3 meter that has a function called the mega ohm meter. Now, what makes it different from this meter? They're both category 3 1000 volt rated. Well, this is also a DVOM, volts, amps, and ohms, but over here we have an auxiliary port for a special probe that can be attached to some circuit or component to check it for insulation breakdown under high voltage. So instead of just putting out a little bit of current like a normal ohm meter does, the mega ohm meter can put out not high current, but high voltage, up to 1000 volts of very low current, and that will be the way to see beyond 1,000,000 ohms. We can see into the hundreds of millions of ohms of resistance, because sometimes all it takes to set a code for a high voltage leak in any of the components or cables is just the teeny tiniest little leakage between the center conductor and, let's say, the shield right here. So not even a pinhole is required for a leakage to shut that vehicle down for safety's sake. You might think of those shutdown circuits like a GFI in a bathroom or a kitchen. Ground fault interrupter, this is a very high-tech solid-state version of that, and this little tool can find out where the high voltage is leaking by checking cables and components along the way, much like an ohm meter, only times 100, exponentially more sensitive. So a mega ohm meter, in addition to the test equipment and personal protection equipment, safety equipment, there is the scan tool issue. Now, most all of you watching today have probably a very good scan tool. Some of you may have a factory scan tool. And you know, if you have a factory scan tool, the distinct advantage when looking at certain modules outside of, let's say, the PCM, obscure body or chassis modules, that a factory scan tool will get in there and not have the holes of coverage and operational functions that the aftermarket OE level scan tools sometimes have. Now, how can you afford every hybrid manufacturer's factory scanner? You can't, but remember, what was over half of the hybrids on the road? Toyota, Lexus. So if you had a Toyota, Lexus factory scan tool, which we do, kind of, sort of, you can really do a bang-up job on diagnosing these hybrids. And every advantage you can get on a complex vehicle, more complexity increases than we've ever seen since computers showed up on cars in 1981, is what we're looking at with hybrids, which would have been out, by the way, since around 2000 or 2001. So these vehicles are breaking, they're getting out of warranty. If you let the customers know you're qualified, watch them come in. If you have a factory scan tool for a Toyota, great. How do I have it if I don't have one? How do I know if I have one? If you have a J2534 universal programmer, you have the Toyota factory tool. All you are is a subscription to Toyota TechStream away from having the factory tool. Simply go to Toyota's factory website and then download and get a subscription for whatever you want, 2 days, a month, or a year, to make your laptop into the factory tool using the J2534 Universal Programmer as the pass-through device to do factory scanning, configuring, and flashing like you may need to sometimes on a hybrid, and only a factory tool can do the job. So we'll demonstrate that later live in this live cast with a little pre-recorded section on the diagnostics. So $1,700, $1,500 to $1,800, somewhere in that ballpark for a J2534 by itself. You supply your own computer, and now you have a factory Toyota scan tool. Also, in addition to mega ohm meters, we have something called a micro ohm meter, as you see here on the screen. The micro-ohmmeter, mine cost about $350. It measures resistance down into the tiny thousandths of an ohm. So not just 0.1 ohms or 0.01, this is 0.001. So when would you want to do that? Certainly not looking at a taillight ground, but looking at the resistance differences between one or another of the phases of the stator windings in the electric motor generator. So when you've got degradation and performance issues that maybe haven't set a code yet, so advanced diagnostics, going down the road, looking further with your crystal ball, what might I need down the road with hybrids? Not to get started, but later when I'm starting seeing more and more car count, a little micro-ohmmeter is also a nice accessory. Now what's similar with every hybrid is the fact they all have a 12-volt battery. If the hybrid, such as Toyota, Ford, Lexus, Nissans, if it does not have a 12-volt electric starter, it still has a 12-volt battery. The 12-volt battery is simply there to power up the modules and to keep codes when the car is shut off. So it's an auxiliary battery, not a very big battery, maybe in the back, maybe in the front, maybe AGM, maybe a lead wet battery, but it's a 12-volt battery. So all hybrids have that, and all hybrids have a high voltage battery. 95% of them in the back for weight distribution. A few of the Euros, you may see a lithium-ion battery pack, which is coming on more and more popularity. The car I drive is a 2013 Malibu hybrid. It has a lithium-ion battery pack in the back. Nickel metal hydride, still the largest percentage of hybrid battery technology out there, and they put them in the back because they are heavier. But regardless of where they're mounted, they'll have various voltages such as 42, 110, or 300, depending on the type of hybrid from General Motors. From Honda, we call them medium hybrids, where you have both the engine and the electric motor running at the same time to move you down the road. Those are anywhere between 100 and 144, 158 volts, whereas the Toyotas, the Fords, the Lexus, those are the full hybrids that will run in true EV mode, no engine, just creeping around at lower speeds. If it's a pluggable hybrid like a Chevy Volt or a, let's say, a pluggable PHEV, pluggable hybrid electric vehicle like some Toyotas have the option or some of the new C-Max Fords, those will have longer range, but they will also have a plug to plug into the back of the vehicle to charge them at night. Now, inverters are something that all hybrids have as well as EVs, electric vehicles, where you have no gas engine. An inverter's job, and sometimes they're called converters, called AC to DC converters, but an inverter's job is to change the DC high voltage in the battery pack to AC, alternating current, three-phase. So just like the alternators we've had for years had 3 stator windings and 6 diodes, 3 positive, 3 negative, for 3 phases, this is 3-phase AC as well. So 3-phase AC is not new to automobiles, it's just kind of new to the outside world of the alternator. Big orange cables, 3 of them. Motor generators each have a set of 3 3-phase AC cables. So that inverter is changing DC to AC, and when the vehicle slows down, instead of using all friction brakes, we can put a greater load on the motor, which now becomes a generator, like in making the field come on real hard on a generator on a vehicle. We'll make the field come on hard and make that generator charge harder and harder, and that slows the car down more and more. That AC that generator is producing is 3-phase high voltage AC. It's changed by the inverter back into DC. So the comparison here of these two pictures, an AC inverter like you'd buy at the big box store, plug into the cigarette lighter, and now you've got something you can plug your drill or maybe a laptop power supply into on a long trip. That's changing 12 volts DC into 110 AC. Very much similar operation going on in inverters and hybrids, as well as the reverse, changing AC back into DC, like in regenerative braking, for example. That is done via diodes in a normal alternator, which is also done inside the inverter. So every hybrid has the inverter, and every hybrid has a converter, DC to DC converter. What's it do? It's just a step-down transformer. If you've got 100 and some volts or 200 and some volts in a battery pack in the rear, constantly being recharged thanks to the motor generator in generator mode, and the inverter changing the AC back to DC, now that supplied and constantly recharged DC source of power can be dropped from 200 or 300 volts down to 14.5 volts to make headlights and water pumps if they're electric in some cases, and everything else, radios, power windows, and the 12-volt auxiliary battery recharge, all the normal things that an alternator does. So when you raise the hood, you won't see a traditional alternator on any hybrid. You'll see something on some GM belt alternator starter systems that looks like an alternator, but it's not really an alternator. It's actually a 3-phase high voltage motor generator. But all the other vehicles out there besides the GM BAS, like Toyotas and Fords, you raise the hood and you'll say, where's the alternator? It doesn't have one. It's a solid state version of an alternator called a DC to DC converter. Now, as far as propelling the vehicle, starting the gas engine, doing regenerative braking, these are done by the electric machines that we call motor generators, or MGs is a short term for them. Honda puts one between the transaxle and the engine, and they both work together, the motor generator and the engine, called a parallel hybrid. General Motors, I mentioned, belt alternator starter. You raise the hood and you go, oh, that's an alternator. And you see these 3 orange cables or 3 blue cables on the earlier versions that were only 42 volts, therefore under 60 volts, which is the threshold for danger. Orange cables means it's over 60 volts. So some of the early ones blue. The one that I have in my driveway at my house, my 13 Malibu, is orange. It's a 110 volt system. It's not an alternator, it's a motor generator. That's what GM uses. But here's a twist of things. Hyundai's hybrid has both a motor generator between the transaxle and engine, like a Honda, and also one on a belt-driven accessory. So one's done for regen, and the other one's done for helping propel the vehicle, give you a little bit more oomph from your 4-cylinder engine. Toyota, Ford, and Nissan, and the General Motors 2-mode full 300-volt hybrid, they will put 2 motor generators in their transmission. So that's what's going on there. And since we know that Toyota, Lexus, Nissan, Ford, they're very similar in technology, they comprise over 60-70% of the market. Most your hybrids you'll see in your shop, 2 motor generators inside the transaxle, and that's what's going to propel the vehicle in EV mode, assist the engine when you're driving with both the engine and the electric motors, and then give you regenerative braking when you slow down. Also, start the gas engine like a 12-volt starter motor used to do. And then, of course, if it's a pluggable hybrid, you'll have a 4-hour recharge time for extended EV range, like on a Chevy Volt, done with a 110-volt charger at your house, or if you wired in a more expensive charger, a 220-volt charger, it does it in 4 hours. I misspoke there, 8 hours if it's a 110-volt charger. And if it's an EV like a Tesla or a Nissan Leaf, that's all you've got to keep your vehicle going from commute to commute, a true electric vehicle. Let's talk about the safety of, let's say, working on the Generation 2 Prius 04 to 09, very prolific vehicle you're bound to see in your shop, at least for oil changes right now. Why not snag some of that diagnostic work, new battery packs and so forth? But we got to be safe. There's a new Nissan Leaf with the little flapper up. We're going to recharge that thing every night to go into the office the next morning. Those vehicles will all have those warning stickers throughout. Here's one from Honda that says, "You will be killed or hurt. Do not remove this cover, no serviceable items inside." Well, that's for the do-it-yourselfer and the amateur tech. For the professional tech who's had hybrid training, you will need to get in some of those covers and do things. And you will need to use safety precautions. So just like the professionals that go up in those bucket trucks and work with transformers and high-tension cables with high voltage, they go into work every day with the same attitude and the same goal we have. We need to do our job, enjoy doing it, and go home and see our families. That means we got to stay safe. So let's talk about personal protection equipment, the high voltage gloves, when to use them, when you don't have to use them, how to take care of them in this little pre-recorded clip. When working with hybrid electric vehicles and electric vehicles, you want to stay safe. So I want to talk a moment about high voltage protection equipment such as gloves. So your personal protection equipment, class 0, 1000 volt rated gloves. Whenever you get them out, you want to make sure every 6 months they've been certified by a professional glove testing company. Secondly, you want to test them each time you use them, before you use them and after, to make sure you didn't maybe poke a hole in them, by seeing if they hold air. Also an inspection. You can blow in them or roll them up. An inspection to make sure there is no signs of any leakage or split that's going to take place. Remember, the Class 0 1,000-volt rubber glove protects you from high voltage, and then the leather cover must be worn to protect the glove from the sharp things and edges on the vehicle. So once we are gloved up, now we can remove a panel or something, use our meter, and make sure truly the circuit that we think is dead is dead. Once we've done that, now we can take these cumbersome and hot rubber gloves off, and you can wear whatever gloves you prefer, whether they be nitrile, latex, or just mechanics gloves, whatever you want to wear in the vehicle, to then do your R&R of a component in order to make sure that you're doing the job right. Wants you to stay safe working on these vehicles. It's all about knowledge and respect of high voltage. A very effective safety procedure when working on hybrid electric vehicles and electric vehicles called the live dead live test. Let's just say you're going to remove a component that has high voltage cables going to it. And you've done the proper power down procedure, but you want to make sure that it did in fact power down the high voltage before you take these gloves off and start using tools to remove various hardware to get components off the vehicle. What we're going to do is we're going to take our meter, we're going to turn it to DC. If the engine's not running, we're not producing any AC yet. So let's go ahead and turn the meter to DC, which it is right now, set to DC. And now we're going to check the meter to make sure it's working okay. Now I know that sounds kind of silly, but how many times have you accidentally had the meter in the wrong position? You had it on AC, you meant DC, or you had it on ohms and you meant volts, or maybe you forgot and you had it using as an ammeter yesterday and you had these leads in the wrong spot. So we don't want to make a mistake like that and see 0 volts when we actually have high voltage underneath this cover. So what we'll do is we'll go ahead and get a known good ground, and we'll go to something we know is good power, like this jumper bar on this bus electrical center. And if we see 12.5 volts, we know the meter is working. We don't have an auto ranging issue or connection or a fuse, whatever, causing the meter to not function and show 0 when it needs to be showing live voltage. So 12 volts is fine, that's harmless. I've removed the screws already on this Generation 3 Prius inverter cover, and when I pull that cover off, now I've exposed potentially high voltage. Now with the system shut down, the power button's been switched off, and that safety plug has been removed from the battery pack, this should be dead, but just to make sure it is, we made sure the meter's working, that's the live part. And now we're going to move our hands over here, and we're not going to use chassis ground because high voltage does not share the common chassis ground in the vehicle like the 12-volt system does. These two cables coming in under this orange conduit right here, 1 and 2, those are the 2 terminals. That's your power and your negative, positive and negative, 200 and some volts from the battery pack if it were turned on. It's not. But to make sure it's not, I'm now going to, one at a time, one hand out, one hand in, I'm going to perform the other part of the live dead live test. This would be the dead test, hopefully. So now the other hand is out, one hand is in. Now we have good connection. We have 0.0 volts in the meter. Now we go back to a live source once again, just to make sure nothing happened in that period of a few seconds. So back to my 12 volts and ground. The meter's working. Live, dead, live. This has been confirmed. This circuit is shut down. Now, I might add that before you put those gloves on, we need to make sure that we take off any kind of jewelry. So a gold ring, a great conductor, a watch band. Take all those items off so that you don't have any conductive things on your body. Now, I made a mention about that one-hand rule, one hand in, one hand out. Actually, where a lot of electricians have got that is handed down over the years. For me, it was from my grandfather who worked in a steel mill as an industrial electrician. And the idea is if you are being electrocuted and you have the other hand involved in the circuit, basically now the current goes in the left through the chest, across the heart. That's the part we're really concerned about, and out the other hand. Voltage, high voltage over 60 volts is an issue. They always say the current is what you're really concerned about. Current, even 100 milliamps, if the voltage is high enough, can be deadly. It can cause cardiac arrest, it can cause respiratory failure and burns that burn from the inside out. So we're dealing with the potential for amputation as well as your heart stopping. So using the one hand rule also is another added layer of protection for you, to include with the gloves and so forth. Now, so let's go ahead and start talking a little bit about what I call the third rail. DC is just as injurious and potentially hazardous as AC. In fact, subways, that third rail they talk about all the time, has the high voltage on it. They say never touch the third rail. Well, what are the third rails, so to speak, on a hybrid? Well, anything that's got the sticker or the warning decal or danger, high voltage and so forth, and that includes the battery pack, typically in the back of the vehicle. It would include cables that are moving from the rear to the front or under the hood, orange cables, and that make sure you don't have your lift arms pinching them. Inspect them for decay, inspect them for maybe rodents or whatever chewing into them, accidents that have caused them to be compromised. Typically it'll shut the vehicle down like a good GFI will shut down a circuit in your bathroom or your kitchen. Also capacitors that store 450 volts or more under the hood, inside the inverter. Those can stay powered up. Now, I have never ran into an incident where it can happen, but the potential is there. They normally power down, depending on the OE, in less than a second on some, like Toyota, or up to 45 seconds, like on some older Hondas. And that's pretty quick. But that's an active capacitance bleed down circuit. That means it has to be solid state applied. If that fails, there's a backup circuit, much higher ohmage resistance that drains off those capacitors, because capacitors are just like batteries. They store voltage, and at 450 volts, after the vehicle's been powered down, you think it's safe, could still be there and discharge into you. So always wait about 10 minutes. We'll get into procedures on powering down the vehicle here in a minute. But that's another source of the third rail of hazards, so to speak. And of course, AC compressors can be hazardous if they have orange cables going to them as well. Now, every OE has a specific procedure for powering down an EV or HEV in order to work on high voltage accessories. Now, if you're changing oil, headlights, you're doing work on the air conditioning system like a recharge, typical service of the vehicle, you'll never have to worry about putting on these gloves and measuring circuits and powering down the high voltage system. But if you're going to remove a transaxle with motor generators, you're going to pull an AC compressor off, you're going to put in a new battery pack or an inverter or converter, you want to follow the steps. Now, if in doubt, you can follow these 5 steps, which are extra cautious, which is I prefer to do, but always follow the manufacturer's procedures over anything you hear in any aftermarket training class. But number 1 would obviously be to turn the key off. I don't care if it's a hybrid or a non-hybrid, you want to get the vehicle powered down first before you do any service. So the key, turn to the off position, or on smart key systems like in a Prius or a Lexus, Nissan, hit the power button and get the dash dark. That's your first step. The second step is to disconnect the 12-volt battery. Now, that's not required by most OEs. That's my personal added layer of protection, because I know once the system's powered down, now there's no DC to DC converter working, the engine's off, there's no action going on. Now, if I take the 12-volt battery cable off, the negative, what will happen is that source of 12 volts is responsible for allowing the contactors or relays inside the battery pack to turn on and close and send high voltage with high current up to the front of the vehicle from the battery pack. That's not going to happen because the 12-volt cables has been disconnected. So on vehicles with smart keys, where there may be a fob like in the console that nobody knows about, a service writer slides across the seat, puts their foot on the brake, and pushes that power button, which is the procedure like on a Prius to get it to power up in what's called the ready mode. And that's when high voltage comes online. I don't want that happening. So I take the 12-volt battery cable off so mistakes like that can occur. The third step is to remove the service plug, or in the case of Hondas, flip the service switch off. It may be called a service grip or a service disconnect switch, high voltage disconnect switch, whatever it's called. Find it. It's different. We'll talk about that coming up next, and different for each vehicle, but find it and remove it. And then the next step, we mentioned before, those capacitors that are high voltage, give them 10 minutes just in case those active discharge circuits didn't work like they're supposed to. And that gives you a little extra edge, so you're not going to be walking into touching some kind of circuit, let's say a transmission removal, and those capacitors are out there and they haven't discharged. They discharge into you, it could be fatal. And then the fifth step is with the proper personal protection equipment like the gloves and some eye protection, take a measurement like we use the dead live procedure to make sure that whatever I'm getting ready to remove is dead. And now these sweaty, cumbersome gloves can come off and your normal mechanic gloves come on and you do your business. So those are the 5 steps that I follow as a generic rule. Look at the OEM, see if it differs, follow the OEM over me any day. Now, looking at where those service plugs or switches are, a little sample of ones here. There's the Generation 2, the newer Insight that has a hatchback and 4 doors. You pull out all the trunk stuff in the hatch area, like the spare tire and so forth, and you come up with this little panel you remove, and it looks like a switch or a breaker in a breaker box. The same thing in the older Honda Civics and Accords. You take the bench out of the rear seat, you take the back of the rear seat off, and there's a little panel you remove with 2 torque screws, usually tamper-proof torque screws, and there's that switch you're going to flip down. Notice that technician's not wearing a safety glove. Probably not a good idea. Most manufacturers will suggest that you wear or advise you wear, require you to wear the safety gloves even when dealing with the remote disconnect switches. If you got a Toyota, it's a little smaller than the Generation 1, which was the vehicle that had a trunk. It did not look like the Priuses that we look at today, but it is still a Prius, and they were kind of hidden at the back of the trunk. And then Generation 2 and 3, Priuses and Lexus and Camry, they had them in various locations when you raise the hatch or the trunk, usually an access panel you can get to, and pull that plug out. A very similar plug used by some GM, like the GM2 modes and the Ford Fusion circled right here. That Ford Fusion, in the first several years, Ford Fusion with a Delphi high voltage battery pack and power electronics, inverter, converter. So we were involved in that work with that vehicle to get that back seat down to access this plug that we're looking at right here in the picture. There's a special trick you want to look up in the service manual to getting into the trunk, and near the rear shelf package, about where those speakers are, you'll have a couple little buttons that have to slide against spring pressure. They're like hidden latches for those back seat backs to fall down, and you can find all the power electronics and the battery pack, including the service plug that you're going to remove to get in there and work on the hybrid. There's the Ford Escape Mercury Mariner. You raise the hatch up on that little SUV, and you pull that carpet out, very simple, and the device looks like this. You simply, with the glove on, turn it like a gas cap and pull it out. And what you're doing with any of these service plugs is you're dividing the voltage in the battery pack into half. So instead of a 144 volt battery pack, it's a 77 volt battery pack, or a 72 volt battery pack. Now, when you have 72 volts, that's over 60, it could be injurious or lethal. However, the computer sees low voltage. When you remove that, when you turn the key back on, if you were to do that, the computer would say, that's not right. That's only half the voltage I should see. I'm not turning on those relays or contactors, and therefore the voltage should not be able to leave that battery pack and come up here to the front of the car. So that's the safety of the safety grips here. Now, let's do a little talk about another system on the vehicle, the cooling system. Now, if the safety plugs help prevent you from being hurt, we want to also prevent the customer's expensive power electronics, inverters and converters, as well as the motor generators from being damaged from overheating. So let's talk about that in this next pre-recorded clip. While some of the power electronics, inverters, converters, on some hybrids are air-cooled because they're mounted in the rear passenger compartment near the battery pack, most, like Toyotas, Lexus, Ford, Nissan, and many General Motors products, are up front and they're water-cooled. Now, they use the same coolant, in this case a Toyota long-life coolant, but a different system, a different reservoir right here for the power electronics, inverter, converter, as opposed to the engine's overflow reservoir for the engine coolant. Now, Both systems need to be burped of air. As you well know, if you've worked on any cooling system, having air in a system can cause mysterious heating loss and overheat situations, so forth. You definitely want to make sure that doesn't occur with a hybrid power electronics cooling system. So whenever you remove a converter, inverter assembly, or you have to change out a pump, or even drop the transaxle, which is also cooled with the same long life Toyota coolant, make sure that you get the air out of the system. Follow the manufacturer's recommended procedures. A helpful tool that a lot of technicians that work on any cooling system, especially the power electronics cooling systems on hybrids, use this device called an airlift, where you take the lid of the reservoir off for the power electronics coolant, and this is now makes a nice pressure airtight fit. This will be primed with your coolant. This is after the system has been drained and you're now reassembled your components, tighten your hose clamps up, and you're going to do a refill, but you don't want air getting in there with the coolant. This will be primed with coolant and put down into the reservoir of your water, distilled water, deionized water, and long life coolant, and you put shop air to this other connection right here. That will cause a Venturi effect, and that will make a huge suction right here and pull the air out of the system. When the air is out of the system and you see it hold a vacuum, you'll see vacuum go down in here into the green. Make sure it holds the vacuum. If it does, now you can turn this little valve on, and now that primed coolant will now start moving into this evacuated system, just like charging an AC system. And you'll pull the coolant in, void of air, into the system, and it's a very, very effective method for maintaining an air-free power electronics coolant system. Now, unlike the mechanical cooling system on a hybrid vehicle, which traditionally are mechanical pumps, and on the Generation 2, they do wear out, typically around about 100 to 140,000 miles. Just basically start wiggling like any old bad water pump. On 2010 and newer, the Gen 3 Priuses, it's now a 12-volt electric water pump for the engine's cooling system. But for the power electronics, they've had an issue. You'll see a service bulletin in the mid-2000s on the Generation 2 models for the power electronics to cool this stuff. These motors had an issue, so there was a bulletin, and you put a new pump on. You may run into this as a technician working on hybrids, Priuses. Not too bad to get to, headlight removal on the Generation 2, and this thing will pop out. You put a new one in. So basically all it's going to do is just move this coolant to keep it cool so we don't have an overheated inverter or converter, two very expensive components on the vehicle. Let's take a look at PIDs now and see what the temperatures are running on this particular Prius's power electronics coolant system. Well, using the Delphi J2534 universal pass-through, I'm able to do some Toyota factory scan tool testing, and I made a custom PID list. Now, before this gas engine fired up, I turned on the AC. We heard a little coffee grinder noise of that electric AC generator, no pun intended, AC air conditioning compressor. And that was making some noise, but also making some noise was the pump motor that we have for the power electronics. So there's the water pump, the inverter coolant temperature, 95 degrees. The inverter MG2 is up to 111. That's the larger of the two motor generators. But the actual water pump revolution, 3250, is 62% duty cycled off and on. That's what's the lifeblood of moving that coolant around to a section of the radiator that is assigned to just cool power electronics coolant through the inverter converter assembly right here, also down into the transaxle to cool the area around the windings of MG1 and MG2. So numbers you're seeing here from the 90s on a hot day up into the low 100s are very typical. When you start seeing numbers exceed 130, 140, then we may see a trouble code set, and we also might conclude we may have an issue with a leaky inverter coolant system, just like a leaky cooling system on an engine. Once we have a leak or a pump that doesn't pump, we have an overheating condition. Instead of a bad engine, we have bad power electronics or bad motor generators from overheating them as well. Now the engine is shut off, And we can hear that electric AC compressor still working because we're in the ready mode. The gas engine's taking a break to save fuel, called idle stop right now. And we still are running the power electronics coolant pump at a 62%. Let's go ahead and turn off the AC, which is using alternating current from the inverter, the air conditioning compressor, which is electric. We'll turn off the air conditioning. That'll lessen the load on the inverter, so it's one less thing it has to do is create that voltage to go on through to it. And we can still possibly hear that electric pump working. Now, to determine if it truly is working, let's go ahead and get it running again with a lot of load on the inverter. Now we'll reinitiate communications. If you really want to see if the power electronics coolant pump for the inverter converter is working, not only the data PID, but also you can look down in the reservoir, and if it's moving coolant, you'll see some turbulence down in the reservoir for the power electronics. So as I take a peek down in here, I do see activity. I see some swirling around of that Toyota long life coolant mix in my power electronics reservoir. We know it's working. This is a Generation 3 Prius, which uses a DC fed AC air conditioning compressor, electric compressor. Now, earlier models, the Generation 2 and some others, used three-phase AC provided by a sub-inverter inside the inverter, main inverter housing, three little cables, orange, going down to that AC compressor, whereas this one has its own inverter built into the compressor. CAN bus circuit controls it via the hybrid control module working with the HVAC programmer, and gives that command on the CAN bus to the little inverter built onto the AC compressor way down in here, and that's going to run that compressor at a different speed. They are quite noisy, by the way. There's a TSB for, like, I believe 2010 models that you can slow that thing down with a reprogramming of the HVAC controls. Your AC may not be quite as peppy as far as cooling it after that's done, but that noisy coffee grinder sound we talked about will be a little quieter. So you might tell your customers, you know, which do you want, a quieter compressor, or do you want a little colder temperature? Sometimes you can't always have both, but if the customer has knowledge, you can help make that decision. But that's a neat trick, using a flashlight and letting that little pump, that pump's very quiet, by the way. You definitely have a hard time hearing it over anything else, but looking to see if that's moving, and that actually is something you might use in lieu of a scan tool, just to see if the turbulence is going on inside the reservoir. Let's go ahead and talk about some more diagnostics. I know a lot of you have tuned in just for that. We got some pre-recorded material on this car just a little bit ago, working with the master warning indicator, that dreaded little triangle that can come on a lot of hybrids, as well as the most popular code I've seen, the P0A0D interlock circuit code, and some no-start tips on writing service repair orders and thinking outside the box of a non-hybrid vehicle. A very common component on hybrids for safety's sake is the high voltage interlock circuit. Now, the word high voltage is a bit of a misnomer. It basically prevents you from getting exposed to high voltage by use of a lower voltage circuit, kind of like a sensor circuit on an ECM. And this little sensor circuit, whether it be 12 or 5 volts, is pulled low when it's plugged in to the component that it's part of. In this case, we have this inverter cover. Now, this is a small inverter cover on Generation 3 style Priuses. But prior to Generation 3, we'll say a 2008 or 9 or 6 or 4, whatever Prius, was a much larger cover that covered the entire inverter converter assembly. And it also had something very similar to this, a shorting bar basically, that went into that lower voltage supplied sensor type circuit called the high voltage interlock circuit to tell the computer that indeed this little plug is inserted in place in the inverter itself, so that when it's removed, the computer sees it's removed and assumes somebody's tampered with a cover and, oh my gosh, they've exposed high voltage to the outside world, to their fingers and prying eyes and so forth. So it doesn't allow the high voltage battery pack to turn on, the relays don't turn on, and high voltage is no longer going to be exposed out there to a technician or a do-it-yourselfer. Now, there may be an occasion where the service manual will lead you this way, or you need to do live testing, and of course, removing this cover to get to the terminals to do your live testing is going to kill the system. So what can be done is this shorting bar can be removed like so, and then carefully in the right position, remember how it went, with a pair of insulated pliers with your class 0 1000 volt gloves, you could put it in to the spot where it came out of when the lid was removed. There we go. So now it's down in the hole, so now we can power this system up. This is not something you do, I repeat, not something you do if you're new to hybrid service, have not had the proper training, and have not been instructed to by the OEM manufacturer's instructions. So, say we have been instructed, we are trained, we can do our live dead live again, known good ground, 12 volts, my meter's working, 12.96, great, all right. And now we will go ahead and go negative right here. And if I get it wrong, no big deal. The meter will just say negative 200 and some volts, and positive over here on my 2 DC high voltage lines coming in, and they're dead right now, or about half a volt, that's fine. When I go and put that 12 volt battery cable back on, if I removed it, and put my service plug back in, or service grip back into the battery pack, close it and compress it. Now I can then see if we have live voltage up here once I put my foot on the brake, hit the power button to ready the vehicle up. So let's go to the back, get this thing readied up. Foot on the brake. Got a ready light. Remember, just because the gas engine is not running, doesn't mean the vehicle is not readied up. We had 215 volts even before the engine started. That's DC. Now we can move the leads over to the AC coming from motor generator number 1. That's the one the engine's going to be turning right now to produce 3-phase high voltage AC. Let's check that out. Turn our meter to AC. Just a few millivolts of unrectified current there. And you just pick 2 of the phases, it don't matter which 2, using your class 0 1000 volt gloves, because we are working live. And we have about 180 volts of AC. So if we moved them over here to MG2, that's the one that goes to the wheels. And you'll see that goes to 0 after that engine shuts down. So no longer is it running. Now if I wanted to see the engine cranking, I could gas the gas pedal several times. That little trick does not work on a Chevy Volt, but it does most other hybrids. You could goose the gas pedal to the floor several times. I'll do that. And you'll watch that meter go from 10 volts of AC, which is a little bit of eddy current right now, to a much higher voltage. So that's just me goosing the gas pedal, the accelerator, throttle by wire, but it's an input to that PCM. It says, hey, gee, what's going on? I think they want the engine running, and that's going to make MG1 become an AC source of power, DC, inverted to AC, down to MG1, turning one of those gears in that planetary gear set, cranking that gas engine over. You're doing live testing. That's with the high voltage safety interlock defeated, if you will. Again, an advanced procedure for advanced techs, if required by the OE. One of the most common problems we encounter in diagnostics with hybrids is the infamous P0A0D, high voltage interlock circuit. Now that circuit goes throughout the vehicle's high voltage components, including the service plug itself. In fact, most techs who have worked on a hybrid, like a Toyota or a Lexus, with this style of safety plug or service plug in the battery pack have done this at one time or another. They have removed the unit, which is essential to separating the two halves of the battery pack, so we only have half the voltage. And when that half the voltage is sensed by the battery pack module, the battery pack module will not turn on the relays or contactors, and that keeps the high voltage from going from the battery pack up to the front of the vehicle for the inverters, converters, motor generators, and so forth. So it powers the system down. And when that happens, it's because you, first off, you extended the safety plug like that, and that allowed you to then ratchet it out, pull it out like so, and when you pulled it out, these two big terminals, which shorted together and completed the circuit of the high voltage battery pack, now it can be removed, and we basically cut that battery pack into half voltage. But another thing that happens when you remove this is you unseat a connection right here. So if we can zoom in on this little bitty low voltage set of terminals, and the misnomer is it's the high voltage interlock circuit. But these little terminals are a shorting bar basically. And when you compress the service plug like so, you can see that little set of jumpers, that little shorting bar in there, engages now a circuit that goes to the computer that's part of the high voltage interlock circuit. When that thing is removed like this, just unlatched, not removed, but unlatched. So the high voltage battery pack has still got a complete circuit, but the small lower voltage watchdog circuit, the high voltage interlock circuit now is open, and the code is high voltage interlock circuit voltage high, and the vehicle will not start because it assumes somebody has tampered with something related to high voltage. So the trick is always to go make sure on your Lexus, Prius, even some Fords use the same style of plug on passenger cars, you have compressed that to shove that shorting bar in. That's the last step of reinstalling the service plug on any of the Priuses. So it kind of looks like this. If we were to demonstrate it from the aspect of the actual connections, that then connects these two together, and then these two wires, which would go in here to the computer, low voltage, let's say 5 volts, now they're shorted together. It's a completed circuit, just like remembering to plug in your intake air temp sensor when you change an air filter. So that's the first thing we look at if we have that code. Now, what does that code cause? Is we look at our TechStream Lite. Now, this is a J2534 pass-through mobile reflasher. This is a programming tool, but it's also a scan tool. So a lot of the companies that are doing both flashing and scanning, like our Delphi tool, we can use the scan tool to completely scan the vehicle for data PIDs and DTCs and so forth. Or if you have a J2534 pass-through, you can turn this into the pass-through for the Toyota factory software. So I recommend, if you have a very stubborn, very difficult hybrid problem or any other kind of hybrid or non-hybrid Toyota Lexus issue, and you have a J2534, go ahead and subscribe to the Toyota TechStream right through Toyota's factory website and download that software onto your laptop so that your J2534 universal programming tool is now the factory scan tool. And that's what we're looking at right here on the screen. I'm going to do a health check of all modules. We've already checked all modules present on the vehicle. You see the list in yellow here. I'm going to limit it for time's sake to just powertrain right now because I have a no start condition and I have that little triangle, the master hybrid warning indicator on the dash. So I have a tow-in situation. It won't even run in EV mode. The gas engine will not crank or run. Basically, I can listen to the radio, put the windows up and down. That's about all I can do right now with the P0A0D. Not history, but there right now, a current code. So let's go ahead and confirm. There it is, the P0A0D underneath my little mouse pointer there, and a P3000 in history, which is a battery pack control module code of some kind. So we can go ahead and try to clear this with a little eraser button here, and we'll clear the code, and it will come right back. So we cleared all freeze frames and monitors. Even the OBD2 monitors have been cleared now. All right, so we will go ahead and run those 3 systems within powertrain once again and see if this code comes back. Now, I've made sure that this is indeed seated in the battery pack on this Prius, and it is. So what could it be? It could be another part of the circuit, possibly in the inverter cover or other high voltage accessories on this vehicle, something not latched, something, a cover not in place, somebody's tampered with something, a wire could have broken. So there is the case where we would do back probing of different connections on the vehicle with a DC meter set to low voltage, because we're looking for basically a computer sensor circuit that should be, let's say, 1 volt instead of 5. And that's what's going to cause the P0AOD. Very likely it could be, instead of the most common problem, the service plug not being compressed, could be an issue with our inverter cover. Writing repair orders for hybrids can be a little bit different in some no-start situations on certain hybrids. For example, Ford hybrids, Toyota, Lexus, Nissan, and many GM, like the 2-mode hybrids, they can actually have conditions where the customer complains the vehicle's pretty much undrivable, but it will move. Oftentimes they'll say it has no power, or they'll say the engine seems to run for a little bit and then it just shuts off and stalls. And so the vehicle would typically come in on a hook. They may also complain it rattles or it has a bit of detonation going on, like spark knock. Sounds like drivability, right? Or could it be the hybrid system? Let's talk about that for a moment. Let's duplicate this particular toe-ins condition with the complaints I just mentioned. We're going to go ahead and do a ready up, foot in the brake, push the power button, get this thing readied up. And like I mentioned before, pump the gas pedal numerous times. This trick works on most vehicles except the Chevy Volt. Go ahead and push that gas pedal down repeatedly. And we look at our scan tool PIDs and it looks like, oh, 800 RPMs, calculated load 60%. There's that knocking or rattling we're hearing here, okay? Mass airflow about 4 grams per second, to about what you'd expect for a little engine like this. Fuel pump is on. We don't see any misfires to speak of. Ignition trigger 7, fuel cut condition is on. Let's do it again. More gas pedal actuation. And now we got that gas engine idling again, 700 or 800 RPMs. So you would think we have a stalling condition, correct? No, the engine is not running. That's the speed the electric starter, in this case, motor generator number 2, not a gear reduction starter, is cranking the gas engine. We can go ahead and power it down now, and I'll let the cat out of the bag and tell you what we really did. Not really a customer's car, it's a bugged vehicle by a typical ornery instructor. Take our beauty cover off. And as we can see here, how can the ignition coils possibly work if they're all unplugged? So no spark, it's not a diesel. How did it run? It didn't run. A lot of professional technicians, very savvy at drivability, hear this and they assume, look at those PIDs and they go, this engine's running, it just won't stay running and you can't rev it up. It never ran, it's being cranked by MG1 until that computer says, you know what? We're giving up interest on starting this gas engine, it's not going to start. So keep your theory wide open. Hybrids are a lot different. Keep studying. Yeah, normally you'd hear the whir, 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 whir of a starter of a 12-volt gear reduction electric motor at about 100 to 200 RPMs. But as we saw here, it was several hundred RPMs. We swore it was idling and stalling, but it never actually came to life. Number one question is, this is business related, you can't work on them unless you get them into your shop. An ideal way to begin promoting hybrid service at most shops is to A, advertise you're qualified to work on them. B, run hybrid service discount coupons in the newspaper. C, sponsor a local pro-environmental cause. Or D, purchase a micro and mega ohm meter. Select your answers now on your computer.
All right, Dave, our numbers are in. We've got a 60-40 split with 60 saying A and 40 saying B.
Well, definitely, in my opinion, A is the best way to start. They won't come to your shop unless they think you're qualified to work on them. All the other answers are good answers, but the best one, an ideal way, is just to first off, let your customers know you're qualified. Remember, that's the major stumbling block. They don't think you have the equipment or qualifications to work on that very, Very complicated little hybrid vehicle. Number 2 question is a tech question. It's concerning that infamous P0A0D on a Generation 2 Prius, 04 to 09. Tech A says the service plug is not compressed. That could cause that code. Tech B says the issue could be with the inverter cover. Who is right? A only, B only, both techs, or neither tech? Select your answer now.
All right, Dave, our numbers are in. We've got 10% saying A and 90% saying C.
Oh, 90% of you guys know what you're doing. It definitely could be this needing compressed, but it also could be any other part of the high voltage interlock circuit, which I did mention before, but on the version of this plug that goes into the inverter to the motor generators on Fords, there's actually a tiny terminal that has to be seated as well that has that same circuit in it. So you could actually have good connections of the high voltage 3-phase and not a good connection of the low voltage high voltage interlock circuit. So any of the above can happen. So answer C is correct. 90% of you were paying attention. Thanks. All right. Question number 3. When removing a high voltage component on a hybrid, it's best to first do which? Disconnect the 12-volt battery, A. Remove the service or grip plug from the high voltage battery pack, B. Power the car down via the ignition switch or power button, C. Or D. Discharge the high voltage capacitors in the inverter. Make your selection now.
All right, Dave, our numbers are in again. 11% say A and 89% say C.
C, Charlie, is correct. All right, you got it right. Now, if you did disconnect that battery cable, and that was the first thing you did, if the vehicle wasn't powered down, you may think it's powered down because the engine may be off. Remember, the engines run when they need to on hybrids, and they're off the rest of the time. So if the vehicle's powered up and the engine's off, you take that 12-volt battery cable off. If that's the first thing you do, it's like taking the battery cable off on an old car with a generator. It'll keep running. That DC to DC converter will keep the high voltage and the low voltage systems all fat and happy with clean 14 volts of power. So always do the key or the power button first and then follow manufacturer's recommendations, or you can follow my generic 5-step power down procedure in order to get a safe condition on the vehicle prior to servicing high voltage components. Question number 4 has to do with more of the population of vehicles on the road that are hybrids. The majority of HEVs, hybrid electric vehicles on the road, use which kind of technology here? A single AC 3-phase motor generator driven by a belt. B, 2 AC 3-phase motor generators in the transaxle. C, 1 AC 3-phase motor generator in front of the transaxle. Or D, an AC 3-phase motor generator at each drive wheel. Which is the answer here? Make your selection now.
All right, Dave, our numbers are in. We've got 13% saying A and 88% saying B.
Correct answer is B, bravo. 2 3-phase motor generators in the transaxle. That describes Toyota, Lexus, Nissan, and Ford as well. Now, all the other options up there are out there on different hybrids, but they don't comprise the majority of hybrids out there in the road, including the one at the very bottom, a 3-phase AC motor generator at each wheel. There's even some of those out there on the road. So it all depends on who you're talking about. Majority are using the what's called the split power drive, the planetary gear set, and 2 motor generators working together. Last question, and we'll turn it over to you for your questions. Number 5, a hybrid electric vehicle, HEV, has a complaint of multiple DTCs, diagnostic trouble codes, very low power, and a gas engine that runs for only a few seconds. This may be caused by A, shorted module in the battery pack, B, a shorted high voltage orange cable, C, an interlock circuit, high voltage interlock circuit that's held high, or D, ignition or fuel delivery loss. Make your answers now.
All righty, Dave, our numbers are in. We've got 11% saying A, another 11% saying C, and 78% saying D.
78% have it. And Christian, we've had either a lot of really savvy hybrid techs logged in tonight, or we've both done our jobs right. I've done a good job describing things to you. You did a good job listening and paying attention and taking notes. That is the exact answer. In ignition and fuel delivery loss, if you had any of those things described as high voltage interlock circuit, a module, major battery module shorted, things like that, a high voltage cable shorted, you'd have a shutdown. And if it was a full hybrid like a Lexus, Nissan, Ford, Toyota, you wouldn't have anything going on. You would not have the complaints that we see here of the gas engine being cranked or assumedly idling and stalling. Actually, we saw in a little video, it was actually just trying to be cranked at a higher speed. So if we have the things described there, it's very likely to be good old-fashioned ignition or fuel problems, and we need to go ahead and go after it as such. Now, obviously I couldn't stump a lot of you with my questions. Let's see if you can stump me with your questions. What do we have on the line here for questions?
All right, here we have an interesting comment. It says, whatever type of hybrid, Toyota, Honda, Ford, I worked on, the first thing I did was confirm where the on-off switch was located and marked it with a long piece of survey tape, just in case.
I love that suggestion. Whoever sent that in, you're a very conscientious technician. That's what you need to do. If somebody's starting to get hurt, you want to be able to know where that device is to power down that hybrid vehicle. That's a whole lot more effective than trying to go get some kind of a hook or whatever and pull them off. That's a great thing to do for everybody in your shop. That's making sure that everybody stays safe. So I like that. Go ahead and put remove before flight, whatever, on that service plug so that we know where it is and we can do a removal in case of emergencies.
All right, we've got another question here. It says, you addressed that basic maintenance on a hybrid can be performed without powering down the system, but what about replacing a radiator or inverter cooling pump where the high voltage system wires or components are nearby but not necessarily exposed?
Well, that's a good question, and that would be totally your call. And from what I've seen in the service manuals, you don't have to remove the power from the hybrid system. In other words, the service plug and things like that, if you're not working on the hybrid system. So the proximity, and I've had a lot of techs, when I've done live training, kind of like, oh my gosh, his arm's against the cable. Let me tell you, if that cable's leaking, it will set a code and shut down just like a high voltage GFI, ground fault interrupter in a bathroom or kitchen type of an application. These are very sensitive. However, if you see signs of cable insulation degradation and no codes and it's running, I wouldn't wait for the code to occur and consider all this is fail-safe. You see signs of intrusion, tampering, or damage, obviously you'd want to power it down before you worked on anything in the proximity of those cables. Otherwise, I'm very confident personally of just brushing up against this stuff. Think about it. You do it all the time with power cords around the house. This is not really any different. But if it makes you feel a little safer, especially starting out in the hybrid service business, definitely do it. You can never go wrong with extra layers of safety.
Excellent answer, Dave. We've got another question here. It says, it doesn't matter if you remove negative first when testing AC. I thought it would damage, uncalibrate the DVM.
That's a provocative question and one I've never had posed to me before, and I'll have to do some research and post an answer back. Even if the answer is still inconclusive, we'll get you something back on the Delphi Facebook, on our Delphi social, so we'll have an answer for you coming forth with that. But Christian, I've never heard of that one, of any kind of issues about whether you remove, it's all about safety, of course, but whether you remove the negative or the positive first, if you're connected to, say, the DC or the AC circuits with a meter, I've never heard of it making any kind of issues with the meter or anything else for that matter. But interesting question, though. All
right, we've got another question here, and this person is wondering, where do I get those gloves tested?
Gloves can be tested at numerous places. A lot of gloves come in a package like a leather or a canvas case, and it will say glovetesting.com on there. You just look that up. That's a website. That's a place you really can send the gloves to. Typically $15, $20 is all you need to get gloves tested. I personally have used a company out in New Jersey, Cementex. There's lots of other ones out there, but companies that specialize in keeping the people who work around high voltage, like utility workers, safe with equipment. They will oftentimes have the equipment necessary to do periodic maintenance and testing of gloves like this. And they will actually blow them up larger than life. They'll be huge like balloons. They'll put them full of into a water basin where there's 1,000 volts charged into that water. And if the glove survives all that, they put a time stamp, a date stamp on there, and they send them back to you. If it doesn't survive, if they find a hole, for example, they'll cut the thumb off so you're not tempted to use them over again, as sometimes techs like to use a tool that should have been retired a long time ago because it still kind of works. There's no kind of works when it comes to safety equipment. It either works or it don't. So they'll cut the thumb out, and then they'll put a little circle with an ink pen around the tiny hole they found, and they'll call you on the phone, typically a good glove testing company, and they'll ask you, would you like us to sell you a single glove? And heck yeah, it's a lot cheaper than buying a whole set. You only need one. So you get a new glove for, a modest fee and the test fee, and the gloves are back to you in a few days. So I recommend 2 sets of gloves. 1 set of gloves you can keep in circulation, so when you're having a set sent out every 6 months, while it's out, a Prius comes in, it needs an inverter, it needs a battery pack, things you start wanting to grab when your customers know you can service hybrids. You've got the second set of gloves right there as a backup.
All right, we got a question here. It says, is there any known issue with computer modules losing the memory or saved data that would require a relearn drive cycle or radio codes?
Honda, of course, had the little sticker with a code, a fixed number. It was sometimes in the glove box, and of course, General Motors with the codes that the customer set. A backup code procedure could be retrieved, and of course, VEN radio numbers. The VEN sent across the data bus to radio to lock it or allow it to unlock. As far as the hybrid goes, there should be no difference in the radio or anything like that, and the fact that it is an electrified vehicle, because it's a 12-volt accessory. Should whatever the OEM says for radio resets, and lock, the F-lock systems and so forth, radio should still apply to whether it's a hybrid or not. Now, on the other hand, when it comes to other memories, such as a PCM is a PCM. Whether it works with a hybrid module, hybrid ECU, which is kind of like telling the engine, I want you to do this, and telling MG1, I want you to do that, MG2, I want you to do that. That's still a PCM taking orders from another module, but it's calculating, I need this much spark advance, I need this much fuel pressure, or this much injector pulse width, and so forth. I need to do evap monitor, and if you, of course, disconnect the battery, it's the same old scenario with any OBD2 vehicle. You're going to have to run the vehicles till the monitors run. So no difference with hybrids versus a standard gasoline engine without the electrification. So nothing different there, and of course the unique modules to hybrids like the hybrid ECU, the battery pack control modules, the battery pack monitoring modules, and whatever other modules that hybrid may have unique to the high voltage system, same deal. It may have to be reset to get those codes to reset if you're having repeat problems, intermittent problems. So it's basically the same business as usual when it comes to memory, resets, keep alive memory, all that kind of thing. By the way, though, on the note, since we have a symptom with a normal engine that has a 12-volt gear reduction starter, when the main battery is low, the 12-volt battery, we go click, click, click. That's the symptom. On a hybrid like a Prius that does not have a 12-volt starter like Honda hybrids do and the GM BAS systems do. But a Prius, a Lexus, a Ford Escape hybrid, they only have the high voltage motor generator cranking that gas engine. So you won't notice any degradation of low voltage until the voltage is so low that the keyless entry don't work. The headlights won't come on. It's drastic battery, 12-volt battery drop where the modules don't have enough energy from that 12-volt battery to come alive and power the system up. So a little difference in approaching your diagnostics when it comes to the low voltage 12-volt auxiliary battery.
Very good explanation, Dave. We've got related to batteries here. Question, how long is the expected life of the hybrid battery pack?
Well, the warranties will vary whether you're in a green state that follows California emission standards or one of the other states of the country. But I believe it's 7 years and 100,000 miles, and in California and other green states, it's 8 years and 150,000 miles mandated warranty. After that point, it's your responsibility to pay cash for that battery replacement, which, as you well know, can run several $1,000s.
We've got some more questions here. One says, I have heard that the maximum isolation leakage allowable is, if I'm reading this correctly, 4 milliamps. Are you in agreement with this?
4 milliamps. Well, I'm going to have to theorize, because I got to tell you the truth, I don't know that spec. But I do know that the chart I didn't show you, ran out of time earlier, so I kind of shortened this up. There's a chart that talks about milliamps, and 4 milliamps is enough to feel a good jingle. Maybe even a little bit above that, maybe even pain if you have sufficient voltage, like 100 to 200 volts. So it's not amperage that kills us. It's the fact that there is voltage and even the least bit of amperage. So I think of a lot of amperage in my head as an old-time mechanic. 100 amps, 50 amps, that's a lot of amperage. But with high voltage, 100 milliamps, 60 milliamps is deadly potentially, and definitely we're getting a good jolt and pain down in the single digits. So whether that leakage spec is accurate or not, I'm not sure, but to me it seems like it's a little bit too high. I would like to see milliamp leakage in the microamps, to tell you the truth. In fact, this is so emphatic, the really low amount of leakage that's allowed, that Honda, for example, says in their service manual, if you put a compressor on one of their hybrids that uses the electric compressor, and you don't use the special dielectric, highly insulated POE, polyester, there you go, I figured it out, the POE, special hybrid oil in your system before you put the refrigerant in, they say remove the compressor and replace it. If you run the system, the AC system, with say a PAG oil in there, not the special hybrid POE oil, then you need to replace the system. That means the evaporator, condenser, lines, compressor, receiver dryer, everything's got to go. That's really emphatic. Toyota, not quite that heavy with what you got to do. Now, we have seen cases where people have put PAG oil in. What's the PAG do? The PAG is absorbent oil. It is an oil that is hygroscopic. It absorbs moisture. The moisture in the oil can cause corrosion and break down the windings in an AC electric compressor. Now, will it break it down to the point where it causes you to get shocked if high voltage goes into the compressor and you touch it? No, but microamps of current flow, leaking of a slightly degraded insulation of the winding of the compressor will cause a code and the compressor to shut down for safety. So I'm thinking that number, 4 milliamps, sounds a little high. Maybe add another 0 to the right of that decimal point in the micro or milliamps and so forth, and we might have a better number, because they really, really are overcautious, the automakers, in making sure this stuff doesn't leak and it's safe.
We got another question that came in. It says, when replacing the hybrid battery pack, should the safety gloves be used when handling it, even though it has been disconnected?
Yes, definitely. I'm pretty sure that I think about any manufacturer's OEM service manual you go to is going to tell you to do that. Although technically, when this thing is removed, and that relay now is being told by the computer, do not turn on and allow the high voltage to leave the battery pack on those 2 DC cables, in case those relays or contactors shorted shut. That's always a possibility. You might actually be wrenching on what you think is the cold or the dead side of the relay, and it's not dead. So to get a battery pack out of the vehicle, you got to take not live cables, but dead cables off, but you're not sure those relays shut off. You could definitely measure them with your voltmeter and see, okay, here's the hot side of the relay of an open, contactor in a relay, and it's hot, and this side right here I'm going to wrench on to remove the cables that go underneath the car. They're cold. There's no power there. The live testing. That's great. But what if? The what ifs bug me with high voltage, so I would wear the gloves when I remove the battery pack, because you are going to be taking these cables off, and I would lay it on an insulated workbench, a wooden bench, or a bench with a rubber pad or whatever. And if I needed to get in there to change out a module, contactors, whatever, when the cover comes off, that is the rattlesnake box with the lid off. Then you need to be the reptile handler. You need to be a very savvy and trained hybrid tech with the proper gloves on, because you know there will be high voltage. Even with these service plugs removed, there'll be high voltage, although half of the high voltage available, and half of 300 scares the heck out of me as much as 300.
Thank you, Dave, for all your answers to those great questions. That is all the time we have for tonight, folks. I would like to thank you for tuning in to Delphi's training series with instructor Dave Hobbs, powered by AVI. Be sure to tune in next time. We've got another session of the Delphi training series on September 9th at 4 p.m. We'll see you there. Thank you. Good night.